Hi scholars, so today I'm going to discuss with you the assignment that is due on Tuesday. So let's take a look at the website here. It says you're going to perform two statistical analyses, one which requires a t-test and another that requires a correlation. You must include a question, a mathematical analysis, a graphical analysis, and a conclusion statement. So let's go through the steps of what you need to do and how you do it. Okay? So firstly, in Excel, I asked a question here. Are the beak lengths of A and C hummingbirds different? So these names have been shortened just for our purposes. There's a series of measurements here for the A hummingbird and a series of measurements here for the C hummingbirds. Calculate the means and standard deviations. And if you don't know how to do this or you don't remember, please look at the previous video and seek each other for help on how to do that. So first, we're going to have to do some graphical analysis. And when you do graphical analysis using two different populations but with the same type of measurement, you have to do a t-test and a bar graph. The t-test and bar graph always go together. So first, we highlight our data. We're not going to graph the standard deviation. The error bar comes later. We insert a column. Columns are vertical in Excel. Bars are left to right. So we're going to do a column. And you notice there's a whole bunch of data. It graphed every single data point, and we don't want to do that. So we want to remove all the individual data points. That's a very common mistake. And we want to include only the mean. And notice when we do that, I pulled it down, only 2 bars show up, which is what we want. It graphed the mean, and you can see that by looking at the y-axis. You want to include a title and a y-axis label and an x-axis label. Delete this 1 here, and you can put your own labels in. Okay, well, you don't need to put labels because the legend is right there. Okay, so now we include error bars. Click on the left one, and if we go to layout at the top, depending on the version of Excel, you'll have to find where that is. You usually can right click and find it too. You go to error bars, and you notice you can't do standard deviation here because that's a percentage. So what we're going to do is we're going to do custom. We're going to specify our value. This is a positive and negative value. So what we do is we choose it. We choose the 1.91 for the first column, both positive and negative. And notice now we put it in and we hit OK. And if you look carefully, it's up and down the same value, about 1.91. You click on the right bar and you do the same thing. More error bar options. Go to custom, specify the value. Now we're going to pick 1.03. And we're going to pick 1.03 again. And we hit OK. And we know we're right because we see that here the error bar is very small, 1.03. And this error bar on the left is much larger, 1.91. Now these error bars overlap just a little bit. Is this difference real or is it just by chance? So we do a t-test. We hit equals and we go to the pull down menu and get t-test. We highlight the first array, which is the A hummingbirds, and then we click on the second one, which is the C hummingbirds, and the tails is 2 and the type is 3, and I'll explain on Tuesday why we're doing it that way. And you see that the value is 0.00088 or 0.088%, which is much less than 5%, which means that the difference between these two types of hummingbird beaks is real. It's not happening by chance. So we're going to make a statement here. The hummingbird beaks from the A and C species are significantly different in size because P is less than 0.05. Okay, so that's how you do it, that one in Excel. This is a t-test with a bar graph. Now in the second example, the question is there a relationship between bill length and weight? So in this one species. So we have a series of data of bill length and weight, and in this case we're going to do a correlation. And a correlation always goes with a scatter plot. So we're going to highlight our data, we're going to insert scatter plot, and you notice that you have a series of dots where the x-axis is the bill length and the y-axis is the weights. And you put a title in and put the y-axis label in and the x-axis label in. Just right click and you'll see them. And then in Excel you can click on the points and you can right click and you can add a trend line. When you add a trend line, you can display the r-squared value, and that's going to lead us to our correlation value. You can also have Excel calculate that for you. You hit equals and you go to the pull down menu and hit Correl. You notice you need two arrays. The first array is the first set of data, and the second array is the second set of data. And you see that the correlation value is 0.92. Now remember, we learned from your reading and from the first video on statistics that R value that's close to 1 means there's a positive correlation between the two variables. If there's a negative value, there's a negative correlation between the two variables, and if it's 0, there's no correlation. Here it means that as the bill length increases, the weight increases as well. So just a relationship doesn't mean one causes the other. Now if you really want to prove to yourself, this is the R value. If you want to really prove that this value over here is the same as this value over here, you can square it, and I'm just going to label it here R squared. And I'm going to equals, and I'm going to take that number and multiply it against itself. So D15 times D15. And look, it's 0.8481, which is exactly the same as the graph value for R squared. So it's the same thing. I could have taken the square root of 0.8481 and gotten this 0.92 value. Okay, so if you have Excel, you can stop there, but I'm going to show it in Google Docs as well. So in Google Docs, here is my document with exactly the same data and the mean and the standard deviation. So the first thing I'm going to do is I'm going to highlight my data so I can graph it. I'm going to go to this little figure, which is insert chart, and I'm going to do column again and do insert, and you're going to see that there's a huge amount of data here. It's graphed every single point rather than just the data we want. So I go to this little pull down menu and do advanced edit, go to start, and I want to select the ranges. Okay, so instead of doing this whole thing, I'm going to do the titles, and I'm going to highlight my means. That's the only data I want to do. And hit OK. And now notice that there's an error popped up because I want to combine the ranges not horizontally. I want to combine them vertically because that's the way the data is lined up in the chart. It's lined up vertically. So I hit update, and I see now I have two bars. Now you can see that this y-axis starts at 15, and that can be adjusted, but I'm not going to do that right now. I'm going to click on the left bar, so I'm going to work on doing an error bar, do advanced edit, and go down to the bottom. And you see error bar here, and you hit constant, and instead of clicking on the value, you're just going to type it in, 1.91. I could have typed it in Excel too, but I decided not to do that. I'm going to click on the right bar here for the C hummingbirds, go to advanced edit, go down to the bottom, and notice it's still on A column, so I'm going to click on C and hit go to constant. So notice here that the value is 1.03, so I'm going to type in 1.03. And notice again that the error bar here is smaller on the right than it is on the left, which is consistent with the number values that we've calculated earlier. So we put a chart title in, we put a y-axis label and an x-axis label in, and then you can calculate a t-test. Now, you cannot do this in Google Docs. It doesn't have that functionality, unfortunately. So I go to this website that can calculate the student t-test. Now, if you look in the top left-hand corner here, it's studentstest.com. You type in the values for group 1, and type in the values for group 2, and you choose, this is tails 1 and 2 from Excel, and this is 2, 3, and 1. 1 is when they're paired, 2 is with equal variance, and 3 is with unequal variance. And again, I will explain that on Tuesday. And you can see the p-value is the same as in Excel, 0.088. So we go back to our spreadsheet, and we would type our sentence in after we got our t-test value, our conclusion. So remember, the question, our calculations, our graph, our calculations of t-test, which is part of this calculation, and then our sentence, which is what I'm requiring for you. So let's go to our other part of the assignment, which is our correlation example. We highlight our data. We go to insert our chart. Now you notice there's no scatter here, so we have to go to more, and scatter is right there. Now you can choose these big gray blobs, or you can just do the color ones, which I like. And then you hit insert, and I like to move my chart away from my data so I can actually see my data at the same time I see the chart. You want to insert a title, a y-axis label, an x-axis label. Now in Google Docs it's not easy to put a trend line in, so I'm not going to put that in. But fortunately it's very easy to put a function in, equals correl. And notice it's telling you here you have to put 2 sets of data in. I open parentheses and highlight my first set of data, put a comma, highlight my second set of data, and close parentheses and hit enter. And notice we get the same value, 0.921 basically. And that means that there's a positive correlation between the bill length and the weight. So our statement would be the bill length and weight have a positive correlation. So I hope that's helpful to you, and if you have any questions, please ask. Have a good weekend.